Alright, so for problem number 5, we have 3 minus 2 cosine theta. And so when I graph this, remember we're going to go every 45. So I'm going to start at 0, 1. You could do more points than me if you'd like to. But generally speaking, 45 is at 1.5. 90 is at 3. We have to balance the amount of time it takes to graph this. So 135 is 4.4, so 4.4, 180 is at 5, then 225 is back at 4.4, 270 is at 3, and 315 is at 1.5. So the graph looks like that. And when you graph it on your table, you should see the exact same picture about that we graphed. And then it's going to go around the second time. It actually only goes around one time, but we're done with this particular problem. The next problem we have is simply to graph r squared equals 2 cosine 2 theta. So what I'm going to do is I'm going to take the square root, and r equals plus or minus the square root 2 cosine 2 theta. So y1 equals the square root of 2 cosine 2 theta, and y2 equals negative square root 2 cosine 2 theta. And I'm going to make each circle 1 so that we can have a better chance of seeing this. So I'm putting y1 and y2 both in my calculator. Alright, and when we graph this, we start with 0. And 0 is at 1.4. And then, once again, we see a lot of errors. So 30 is at 1. And 45 is at 0, and so we get an error message. But we have the same thing going below, where 45 is also at negative. 0 is at negative 1.4, so this is negative 1, negative 2, and it goes like that. And then we are at an error until we get to 135, and at 135 we're at 0. And so we're going to basically have a graph that hits 150 at 1 and negative 1. And so we get another loop like this. And so we basically have the infinity sign, and we graphed more of the points that we could see because of so many errors on there. Alright, number 7 is going to be real quick, because this one we have negative 4 comma 50, x equals r cosine theta, y equals r sine theta. So x equals negative 4 cosine 50, and y equals negative 4 sine 50. Once again, make sure you're in degrees when we do this. Negative 4 cosine 50 is negative 2.57. When I change it to negative 4 sine 50, it turns out to be negative 3.06. And that is my answer for problem number 7. For the next one, they're looking for us to write this in polar coordinates. And so the first thing is that r is equal to the square root of x squared plus y squared. So when I plug in the square root of 5 squared plus negative 13 squared, it turns out to be 13.9. Now 5 negative 13 is going to be down over here somewhere, where this is 5 and this is negative 13. So I'm going to use the arctan of negative 13 over 5. And when I do the negative arctan of negative 13 over 5, I get negative 68.9, so negative 69. But to make it positive, I'm just going to add 360 to the answer. So that turns out to be 291 degrees. And that makes sense because 291 degrees should be in the fourth quadrant. Alright, the last one is r equals 6 sine theta. I'm going to put it in rectangular form. I'm going to multiply both sides by r. And r squared, and you don't have to remember this, but we have a formula that says x squared plus y squared equals r squared. And we have r sine theta, which is the same as y. And so now I'm going to just subtract the 6y to the other side. And I'm going to consider this an acceptable answer for this problem. If you have any questions, please email me. Let me know if you need to see another example of anything.